How are you?
Yes, I'm doing great. How about you?
Fantastic, thank you. I love a few good tech. It's not a live show unless there's a few tech issues now, right? Now everyone knows that you're getting brilliant, decent, high quality live content. None of this is pre-recorded, so anyway, I'll leave it over to you. I know you got a fantastic talk lined up for you. Don't forget, everyone, use the hashtag .NETConf to ask all your questions, and we'll be back here at the end of your talk to ask you some of the amazing questions that are coming through Twitter. So over to you.
Yes.
All right, so go ahead and share your screen. We're ready when you are.
I hope my screen is visible. So, today my session is about architecting cloud native application in Azure using .NET Core. So, why not I prefer .NET Framework? Why I'm going with .NET Core? Yes, it depends on your project requirement and how your application working. In some cases, your application need to support multiple platforms, so you can do the same steps for .NET Core. In some cases, you have a third-party libraries that your application is working. So in that cases, you need to work with .NET Framework. So architecting cloud native application can be similar for both .NET Core and .NET Framework. Depends upon the requirements and how your application working. You need to differentiate how you need to architect your cloud native application. Before getting into this topic, I just want to make sure that cloud native application, what is cloud native application? Is it easy for us to work as a .NET developer directly to a cloud native application? So today I'm going to clarify everything from the scratch, and at the end I'm going to say in detail about some new features what Azure DevOps Starter have been, so we can able to incorporate in our daily project that made our work easier. So I'm Menaka Bhaskar. I'm working as associate software engineer. So let's get into our session. So, beginning of the session itself, I just want to get a clarity. Like, I'm a .NET developer. I haven't heard about any cloud native application or anything. Yes, we have been not been heard about a cloud native or something that operation teams does in DevOps. Cell. But as a developer, it's quite easy whenever incorporate our Azure service with our daily application development. So, cloud native applications are nothing, it's built from the ground up, optimized for cloud scale and performance. So basically, compared to monolithic architecture, the microservice is good. Why? Because it have a services that is independent of each other. That any failure in the particular service can be easily monitored, and the fixes can be given easily without affecting the entire application. That's the best advantage of using a microservice architecture rather than traditional monolithic architecture. Though we are being using a microservice architecture, at the same time it has some drawbacks also. In drawback side, we can see means lot of services. When a new developer comes into one project, he feels difficult to understand what services perform which action, and you need to establish the communication between the two services. For example, either it's a synchronized communication or asynchronized communication, depends on your need. So in this complexity, if you made something it works better in DevOps end, or if you want to deploy your application, especially microservice, into your Kubernetes service in a lightweight container, it's quite easy. So that's the reason of working with cloud native application is very easier in today trend. So they are based on the microservice architecture, as I mentioned before. It have the managed services, and it takes the advantage of continuous delivery to achieve the reliability and faster time to market. So client deliverable will be faster whenever we are moving with a cloud native application. In other terms, cloud native is an approach to build and run an application that exploits the advantage of cloud computing in a delivery model. So I choose .NET Core as a perfect blend for cloud native application. As I said before, if we have some other third party library that need to work with your application, there is no other option. We need to go with .NET Framework. So based on the requirement, we can able to create a cloud native application in Azure. Before getting into this perfect blend for .NET Core, we need to discuss something about things which we need for a cloud native application. For example, as I said before, microservice. So if it is a microservice, we need a lightweight container. So obviously, cloud native comes into an action. In other end, that is an operational end, business end, what we need. So my next slide deals with that. So here we are having something that we need for a cloud native apps. So it may help us to get an detailed idea about how it works and how a microservice can be deployed into any services. We cannot say only for Azure Kubernetes services. There are some other services which I will show in my demo. So what are the things that need to be taken care when we are working with cloud native application? So DevOps is main thing, because whatever thing we are doing with a deployment activity, that will be considered with DevOps also. So DevOps. So it is a collaboration between the software developers as well as the IT operation team. So both the DevOps engineer as well as the development team will together work in the deployment environment. So that is the main goal, is delivering a high quality software that solves the customer challenges. So DevOps with the automatic build and release pipeline is one of the greatest gift of the DevOps engineers. So it makes the work easier as well as a fast deliverable. So when it comes to second one, as I mentioned before, microservice. It is an architectural approach compared to a monolithic architecture. It's one of the architectural approach which we need to do for deploying our containerized application. Whenever we have services that being splitted, we need everything to be deployed in a particular container in Azure Kubernetes service. So this is an approach of architecture end where we as a developer need to work. So the second thing is like a container. It's very popular with both the developers and operators because they offer a simple way to achieve deployment and execution consistency. So all these three together, we can able to create a cloud native application. So as in previous slide mentioned, cloud native application is a perfect blend for today's growing IT scenario. So as a .NET developer, it's quite easy for us to work with the operation end when we have the knowledge of cloud native. So the next slide deals with the application of cloud native application. So everything from the cloud, it's a simple word. So we can connect to this cloud native application with that. So we can get everything from the cloud, and it is easy to choose the right tools for the job. For example, I have a .NET Core which have a DB, so I can able to enable it from my Azure portal end, and I can able to choose the tool particularly what need to be work with my application, what is not, based on the cost, conception, availability, serviceability, flexibility. I can able to choose my tool, and it's a productive through the application lifecycle. So the fault management or any issues or the container health service monitoring, everything can be gone through a single view. So in a single UI, I can able to manage everything that my application does after deployment. So this is one of the major advantage of cloud native application. So why for Azure? Why not with other? So if we have been going with the industry leading Azure security, they invest in nearly 1 billion annually with the 3,500 security experts with more compliance certification. That makes to work with Azure quite easier as well as with this security end also. So, microservice in Azure. As a developer, whenever we are developing something on the basis of architectural view, obviously we will start from the monolithic architecture. Even me, as a 2 year experienced engineer, I used to work on monolithic architecture. So the application, when a new developer comes in, it can be easily understood. But whenever the failure, the entire application will be staggered. So that is the main reason why we are migrating to the microservice architecture. Even microservice architecture needs certain amount of depth knowledge or certain amount of knowledge about grpc or communication between two services, but it's very very easy whenever we are going with the distributed cloud application. So that is the reason, and it's the advantage of using the microservice in Azure. So second thing is like it have the build services independently. As I mentioned before, the services being built independently. So particular service space, we can able to fix the issue at particular end without making our entire application to remain stagnant. So it can be save services autonomously, so independent to each other, and it works very efficiently, and it can be uses the lightweight container to deploy, and that's what microservice in Azure works easier with any other application sites. So this is one of the greatest advantage of using microservice in Azure. So Other thing, when after discussing about microservice, we need to go with the next step where it contains the containers, which is also important when we are going with the cloud native application. In an architectural view, we've seen the microservice, how it works, how the service being split up, how the communication, either a gRPC or any normal REST API, or we using a queue storage or anything. It's our need based on the requirement. But if we comes to the container, which is the second part, we need to find the services based on your container needs. For example, if you want to simplify your deployment and you need to manage and monitor your operation of Kubernetes, you can use your Azure Kubernetes service as a containers one. Or if you want to quickly create a powerful cloud apps or for web and mobile, you can go with your Azure App Service. And easily to run the container on Azure without any managing services, you can go with the container instance, as well as cloud scale and scheduling management, everything. It's like a batch. You can go with serverless also. And second thing is like developing a microservice and orchestrating the containers on Windows or Linux. You can go with the service fabric, and you can able to store and manage your containers images across all your deployment using container registry. This container registry is quite important. This is not something different. Usually we will use a Docker. In some cases, for testing purpose, if I want to work with Docker, it's quite some, maybe my system will not support or something. In that case, I can use a Azure container registry. So it's very good to use whenever you want to store and manage your container images across your Azure deployment. So it's quite easy to use. And to run the fully managed OpenShift clusters to jointly operate with the Red Hat, you can go with the Azure Red Hat OpenShift that is readily available to support the Red Hat related clusters. So this is one of the slide where it explains what all the services you need to use depending upon the case of the requirement you have. So we can use the services from our official documentation itself. Okay, what's the difference or why we need a cloud native rather than the traditional enterprise application? So the main reason and the main thing is like it's a predictable one, and it have OS abstraction, and it have the right size capacity. If we haven't going with the traditional enterprise, it can be unpredictable. So failures cannot be monitored at the same time, cannot be predictable. You need to enter architectural where the issue, why, because the particular issue is coming, or why it not yet working with the particular service. So it's OS dependent. So, and another thing is that seeing an application as a whole is very difficult compared to that of seeing a layered application. So the overcapacity is also the reason why we are moving towards the cloud native application. So this is the one of the difference between why we going for a cloud native apps rather than the traditional enterprise application. Anyway, in some cases we need the monolithic architecture in based on the requirements. We have no other go. We cannot do in a cloud native application. In that cases, we have no other option. We need to go with the traditional approach. But whenever we are started from the new, from a scratch new project, it's better to use a cloud native application by using a architecture as a microservice, and you can use a DevOps in your deployment end, and you can use other few things which I'm telling in further slides. So that makes your deployment work as a cloud native application easier. So deploying the .NET Core app in Azure Kubernetes. So today this is what I'm going to discuss. So I'm using DevOps Starter as one of the service in my Azure services, and Docker containerization with Azure Kubernetes, and CI/CD pipelines of .NET Core with Azure DevOps Starter, and it's going to deploy my .NET Core application in Azure Kubernetes. So this is what today's what we are going to deal with, since it's a long process of creating a Docker image and then again using this image, building an image, pushing and publishing an artifact from the DevOps end. I'm going to show the features and the availability of special thing what DevOps Starter have, and how it makes your work easier and reliable. So let's go with the DevOps Starter. So this is what I will explain in detail about the demonstration, which I will show in Azure Supporter. So it's one of the services to build, monitor, and commit your deployments, and everything can be done from a single UI. So quickly deploy your application on Azure, and it will automate the setup of your CI and CD pipeline. That's one of the main features of DevOps Starter. So As we all know, Azure Kubernetes Service, it's used to build, deliver, and scale your containerized application. It have load balancing also, and it may self-heal also based on the issues. And it can able to monitor the issue where and when it comes, and it have the monitoring system separately for the Azure Kubernetes, and it have resources and auto scaling allocation, and it removes the complexity of managing the multiple container deployed across multiple server. This is one of the key feature of Azure Kubernetes Service. So this is how DevOps works with your Kubernetes. So my inner loop consisting of the IDE where I can able to create a cluster. Once it is done, I can able to do my source control. After that, I can use a container registry. Either, as I said, you can use Azure Container Registry, or you can use Docker as a traditional approach. Once after everything is done, it will be in my Kubernetes production cluster. Once everything does, I can be able to check my policy and other things like Helm chart modification or anything. Then I can able to build and release my pipeline. Once everything is done, it will have the loop around the whole like monitoring and logging. Everything can be monitored from the single UI. This is a flow chart how the exact .NET Core deployment with Kubernetes happen from your DevOps end. So I hope this will help. So let's see the demo. So this is a service I told. This is a DevOps starter service. So you can able to create a new service from here. So from a scratch, if you go, you can able to create a service by clicking add. So it will have a .NET. You can have a Node.js or PHP, any application which you need, and you can able to create your own code from here also. So go with this. So click next. So after choosing a .NET, I need to choose either it's a .NET framework or .NET Core. This is also up to our need, our requirement. So it's a .NET Core application. So I'm going with the .NET Core. This is the thing you want to deploy your application. You don't need to do only for Kubernetes service. You have a service fabric clusters and other things you can choose based on your requirement. Since here we are using a Kubernetes service, we can able to choose Kubernetes. So here is the place where your Azure service and your DevOps are integrating. So you need to give the project name and your DevOps organization name. This is a place which is the organization which has already been created in your DevOps in. So use that, and you need to give your subscription detail and other details and your cluster name if you are creating a new cluster. In case if you have some already existing cluster where you need to deploy in the same cluster, you can go with that ahead. So go to your additional setting. You can see your container registry activity which is happening in the background. So this is a container registering activity. So this is auto populated when you are giving the DevOps organization name and other cluster name. If you are creating new, the automatically it will take the name of your container registry. So you don't need to worry or bother about this, and it will be that works on the back end. So once it is done, you need to click, which is I already did something, so I can show that. So you can be able to change your VM size by choosing from this based on your requirement CPU and other. You can able to choose the node count also. Once it is done, you done. It will take some time to get deployed. So this is how my Azure DevOps starter with the pre-built code works with my .NET Core application. If you see, I can able to find my first build and first release being succeeded. So if I want to go to my DevOps, and I can easily go and see my build and release pipeline from here. At the same time, it has something like a project homepage which will take me to my IDE and other things like backlogs and user groups to whom I can give access and other things. And you can see my Kubernetes cluster with the server request which is being given here. So I can able to monitor the health and other features of my Kubernetes from here. So this will contain my Kubernetes related details. I can able to see here with the node pools and other features that Kubernetes contains with the insights of the particular application. So after this, I'm just going back to my DevOps starter. So this is my pre-built application. So this is how my application works with the actual endpoint after it get deployed into the Azure Kubernetes. If we need to change something, we need to do the alteration in our DevOps end. We can able to redeploy the changes. For example, for a demo, if you want to change your HTML alone, like .cs HTML, you can do some changes and you can able to redeploy that in a build and release or automated. So you don't need to do that. Whenever the changes are given, it will get redeployed, and the changes you did in your DevOps end will be auto populated in your application end. So this is quite easy to use when we are deploying our .NET Core application via Azure in Azure Kubernetes. So try to use this Azure DevOps Starter. It is one of the cool service that's readily available to deploy by choosing variety of deployment option with variety of framework. So this is all about a cloud native application. So I hope I completed. Let me put
Wonderful
question.
presentation. I really enjoyed it. We had some great comments coming into the chat, which is amazing to see. Again, I want to thank you for just flying the APAC flag. I love to see this region really well represented. So really amazing. Unfortunately, we don't have time for any questions. But assuming people can find you on Twitter, is that right?
Okay. Thank you.
Yep, people can find you on Twitter. So hit you up if you would like any. If your questions didn't get answered, and please follow Nika, because she's been absolutely amazing and giving up her time to be here and show us all about .NET with Cloud Native. So thank you again once again.
Thank you. Thank you, Michael. Thank you all.